Hi cohort. So now I'm going to do an example of the concepts that we talked about today from the homework. So this is chapter 8, problem number 5. So in this chapter we're given some data, test scores and principal rating. And the question that we're trying to investigate is there a significant correlation between principal rating and test scores? Okay. So according to this one, the first thing says compute the summary statistics required, blah, blah, blah. So really, I think what they want us to do is compute the regression coefficient R. So the way you do that on a calculator is really easy. You just begin by putting the data into your calculator like always. So I've already put the data in for us. So I put the test scores in list 1 and the principal ratings in list 2. And it's really important in this case when you enter your data that the numbers are paired together. For example, this 14 and 7 are together in the table. See that right here? You can't just enter them in any order because the numbers come in pairs. So you have to make sure that the x variable is paired with its y variable. Okay, now once your data is in your calculator, it's super easy to do. You just go to Stat. Now, ordinarily we're doing a test, but we're not doing a test in this one. We're just doing a calculation. So we're going to come over here to Calculate. And the topic of today was linear regression. So we come down here to linear regression, and you just press Enter 2 times. Voila! Okay, so right down here is your correlation coefficient, 0.48. That's really low. That's not significant. Remember, for a correlation coefficient for R to be significant, you want it close to 1. 0.48 is not close to 1. One way of thinking about it, for those who are wondering, well, how do you know when it's kind of close? Think about needing to have $1. And right now, you have 48 cents. You're pretty far away from $1. If you had like 70 cents, 72 cents, 74 cents, that would be pretty close to $1. But right now you have 48 cents, you're pretty close to nothing. So I say that this R value is insignificant. There are ways you can test it, of course, but common sense is going to tell us this is insignificant. And not only that, we can see right up here this R squared value. That means that only 23% of the variation in Y can be explained by your X variable. In other words, only 28% of the variation in the principal rating can be attributed to your test scores. So again, very low. So really, we shouldn't be doing the next step, which the book asks us to do, but we're going to do it anyway because it's a homework problem. Okay, so in part B, it says, using the values, calculate the intercept, slope, state the regression equation. All of that is right here. Your calculator tells you the formula it's using for the line is y equals ax plus b. Here they give you a value for a, here they give you a value for b. So if I were doing this homework problem, my answer for a would be r is equal to 0.48 because the first one asked us to find the correlation coefficient. The second one asks us to write the regression equation, so I'm going to write y is equal to 0.12x plus 5.18. It also asks us to interpret the slope, calculate the intercept and slope. Okay, so the intercept is 5.18 and the slope is 0.12. Now the problem doesn't ask for this, but this is often asked for on tests and exams and in practicality. So if we were asked to interpret the slope, in other words, write a sentence telling what that means, well, that's 0.12 over 1. Remember, that's change in y over change in x. Now, what is y? Y is principal rating, and x is test score. So if I wanted to interpret it, for every increase of 1 point on the test, principal rating increases by 0.12. So that would be an interpretation of the slope.
The next problem says, suppose that 3 teachers apply for the positions at the school and they have test scores, blah, blah, blah. Compute their predicted ratings of effectiveness.
This is a real no-no in the world of statistics. We really should not be doing problem C. The only reason we're going to do problem C is because it's a homework problem. But see this R right here? This R is totally not significant. When R is not significant, we should not be doing regression. Why? Because regression is writing an equation that describes a relationship. But we already know from A, there is no relationship between test score and principal rating. So we really shouldn't be doing this. But we're going to do it anyway because that's what the homework asks us for. But I just need you to know that in your practice and in real life, this is like a huge, huge, huge misuse of statistics. But anyway, here we go. So for example, if you wanted to answer this question, if there's a score of 18, what you're going to do is you're going to put this in the equation for x, because that's where our test scores are. So you would go 0.12 times 18 plus 5.18, and whatever that comes out to be, that would be your answer. That's how you would answer the rest of Part C as well.
Part D says, if in fact these data were real, what objections would you have to using the equation from problem 6b for the prediction?
Well, I think I've already made my objections pretty clear. R is not significant, and so when R is not significant, we should not be writing or using a regression equation. Okay, so that's how easy it is to do simple linear regression. In other words, when you just have 2 variables, in our case, test score and principal rating, using your calculator. Some of you might have really new calculators. I can't remember what kinds of calculators I lent out, but if I lent you a brand new one, when you did your statistics or your calculate, you might not have been able to see an R value. So let me just show you, like, it may be that when you did this, you're only getting a couple of these numbers and not all these others. And you might be worried, like, well, what's wrong with my calculator?
So let me just show you something you have to do. You have to turn on R and R squared the very first time you use a calculator. Otherwise, they're hidden. Most of you shouldn't have that problem, but if I lent you a brand new calculator, you might be having that problem. So let me just show you something right here. It's really easy. You go to second, and then you come down here to the 0 button, which is your catalog. And what this is a catalog of all the functions your calculator does. You just have to scroll down till you hit the letter D. And what we're looking for is a command that says diagnostics on. When a calculator is brand new, for some reason they send it with the default diagnostics off. You just have to turn them on. So go here and click this 2 times, and then press enter, and you're good to go. So when it says done, what's happened is they've turned R on, and now it should be displayed. Okay, not today because I don't have time, but later in the week I'm going to show you, I think, how Sheldon's handouts are used and what I anticipate might be on the final. And I'm also going to bring in some data from my own classes. So I know a question people have is like, so why would I ever want to do multiple regression, or what's it used for, or who does it? So I'll bring in an example from some data from my own class, and I'll try to demonstrate how it's done. Okay, so that's it for now. Good luck with starting your work for this week.